Okay, so I just wanted to continue on here now. So this was your question 4. So same idea here. You're asked to name the A to D. So again, we've had these now previously. So that's ethene. Okay, you draw that one out. That's ethanal. It's an aldehyde. C is ethanol. And oh no, we haven't had this one before actually. Now, when you draw that out, you've CH3, and now the O. Now watch the valency of the carbon. You have to have a double bond O there. So what would that one be? Well, the C double bond O, what's that functional group? That's a functional group for a ketone. So D must be, you have 3 carbons, so it's propan-ON. Okay, first member of the ketones, propanone. B, alcohols can be obtained by the reduction of aldehydes and ketones using hydrogen. And they want you to name, look at the name now again. So you have to write out nickel. You cannot have Ni, they will not give you the marks for that. C then, write an equation. Now that's the preparation of ethene. So do you know that you did that in 5th there? So your ethanol, and then you're forming your C2H4. Don't forget to add the H2O, and don't forget to put the aluminium oxide above the arrow. So that's your equation, and that is elimination, or you could also call it dehydration, but elimination, we'll stick with that. Now, do you remember the 2 criteria for elimination? Right, so if it's an elimination reaction, you're removing a small molecule from a larger molecule and you're leaving behind a double bond, okay? D, now this is a pre-question. Normally in the real exams, they'll give you the actual boiling points of C and D, and they'll ask you to just, to account for the difference. So look at C now. C is ethanol, it's an alcohol. So that can have hydrogen bonds between. So your first sentence is that the ethanol molecules can have hydrogen bonding between them. What can propanone molecules have? D. They can have dipole forces between them. And if you're trying to boil them, you're trying to break all the bonds and separate the molecules completely from each other. So they go from being like a liquid to being like a gas. Which would be easier to break? Well, the dipoles would be easier to break, require less energy because they're weaker. Dipole bonds are weaker than hydrogen bonds, require less energy to break them. And therefore, the propanone would have a lower boiling point than the ethanols. Now, intermolecular forces are one way that you can explain or account for difference in boiling points. Remember, the other thing is the size of the molecule. So the bigger the relative molecular mass, the heavier it is, the bigger the boiling, or the higher, the boiling point would be. But these have relatively similar relative molecular masses. So just watch that. So type of intermolecular force and the size, the relative molecular mass, will account for boiling points. But these are similar, and normally in the organic questions, the compounds they give you will be similar in terms of mass. Now, E, describe how you would carry out. Now, we had this before, the failings test. Remember that you would have to say that you mix equal volumes of failings A and failings B. Say that. Then you would add your compound B, your ethanal, to the test tube containing the failings solution. You must say that you heat it. So put the test tube into a beaker of warm water to heat, and then your observation. So the blue failings then gives you the brick red precipitate. Now, why does that happen there with the ethanal? Remember, ethanal can be oxidized to ethanoic acid. So what will happen to the Cu plus 2 ions in the failings? They'll be reduced to Cu plus, which is accounting for your brick red precipitate, okay? F, name the aromatic. Aromatic compounds always contain benzene, found in almonds, it says, and belongs to B, so it's benzylaldehyde. So it's an aldehyde, but it's an aromatic aldehyde, so benzylaldehyde. And one use of the family to which D belongs to, well, propanone is nail varnish remover, so you could just say nail varnish remover for that. Now, the last question there that you had for homework was the pre-question that you had. So again, giving the systematic names. Now, we've met these before, so I'm going to be quick. Ethane is B, ethene here for A. Okay, now again, look, the minute you see the alkene, you are thinking T has to be addition, X has to be addition. Look at the arrows coming out from the alkene. This is your chloroethane, this is your ethanal, and then finally D is ethanol, okay? Identify a compound which contains at least one planar. Well, A contains 2, so you can say A or E. We had that before. Name. So you had to have writing out hydrogen and writing out nickel. The symbols won't do. Identify elimination. Remember that the only elimination reaction on your course is an alcohol to an alkene. So W there is your elimination reaction, okay? And then the next one says the addition. I've already highlighted T and X. Anything coming out of the alkene there, the ethene, is addition. And then they ask you for reduction. Well, reduction is here, look. All right, it's E back to D, so it's the ethanol back to the aldehyde, or sorry, to the alcohol, so that's Z. Now, after carrying out conversion Y, how could you, again, this is the same sort of thing now, but you must describe it properly, so you'll use adding equal volumes of failings A and failings B. You could mention the other test that we did, the separate test of B-acidified KMNO4, or the third one you could say is the ammoniacal silver nitrate, but be careful to describe them. So say that you added to the test tube containing E, warm it in a beaker of hot water, that sort of thing. F is your free radical substitution mechanism. And then the three pieces of evidence. Now remember we had that butane is formed, okay? Why would butane be formed? It's not a product, but it's formed because of two ethyl free radicals combining to form the butane. UV light is needed. It does not happen in the dark. This reaction will not happen in the dark. Why is UV light needed? To break the chlorine molecules. Remember we talked about homeolytic fission, forming the chlorine free radicals. And finally then try to maybe stick with the three pieces we learned, that if you added tetraethyl lead, the rate, now you need to be careful with the words, the rate of the reaction would greatly increase or greatly accelerate. Why? Because your tetraethyl lead breaks down to form ethyl free radicals, which will go in then to propagation 1, propagation 2, and increase the rate of the reaction. Identify the catalyst used in W. Well, that's your aluminium oxide, and describing its appearance, it's a white solid. Okay, thank you.